This structural X-ray of the Linux kernel is a deterministic build artifact. It extracted 84,486,512 triples and 61,103 AI summaries, each with a verifiable receipt. Crucially, no statement should be taken for granted. Every figure shows its epistemic class, with 10 of 10 hashes matched perfectly. Software architecture of this magnitude inevitably outlives the original authors. Past a decade, the engineers who hold the map in their heads leave, and the design lives nowhere but the raw source code. True codebase understanding at enterprise scale cannot rely on oral tradition or guesswork. It must be treated as a mathematically verifiable build artifact. The current industry standard for answering structural questions relies on asking AI agents to read raw code on the fly using Retrieval Augmented Generation, or RAG. Attempting to assemble massive, interconnected architectural dependencies in real time, piece by piece, causes the entire structure to collapse under its own weight. Reading the live tree forces an agent to rederive structure from scratch on every prompt. It spends its finite context window attempting to map data that a compiler already knows. This process invites a specific, dangerous failure mode. An index that silently misses a file looks exactly identical to a file that does not exist. That creates an unauditable gap in reality. Live tree agentic retrieval has a hard structural ceiling. Feeding language models prose-shaped guesses over raw text guarantees downstream failure. To isolate LLM errors from mechanical truth, this graphic displays three distinct epistemic tiers. On the left, the deterministic fact tier. In the center, the derived tier, containing computed structures. On the right, interpretation, explicitly walled off, model-authored summaries with explicit provenance receipts. This specific visual tone scale maps those epistemic classes to exact ink colors in practical reports. Humans can instantly parse AI confidence versus negatable fact. By structurally separating the mechanical from the interpretive, organizations safely adopt AI enrichment without ever letting it impersonate hard fact. SourcePath operates as a compiler pipeline, mapped here from ingest to the serving surface. The AI interpretation step is integrated but guarded. Before serving, everything passes the verification gate. Failing builds are rejected entirely, while the disclosure rail explicitly records any unparsed data. The absence of data must itself be treated as data. A trustworthy architectural map explicitly declares its degradations, fallbacks, and blind spots. On the consumption side, AI agents attach to this verified bundle via the read-only model context protocol. Delivering structure as compact, exact data frees up the agent's context window. Instead of rederiving basic file relationships, the agent spends its token budget on actual reasoning. This schematic illustrates how graph capabilities compose into structural answers without extra AI processing. First, combining census with test linkage yields immediate blast radius impact analysis. Second, merging chunks with the concept graph allows deep semantic navigation. Finally, appending provenance creates auditable AI citations. Tracking dependencies outward from a single point of failure happens in a fraction of a second with total precision. The real value here is transforming agent output. It stops being plausible prose and becomes mathematically checkable statements. This diagram shows the side-by-side journeys of the AI agent and the human operator. Both must rely on the identical, verified artifact to maintain accountability. On the left, the agent connects to a read-only surface, traverses the graph, and attaches provenance paths to its actions. On the right, the operator compiles the code, reads the verification gate verdict, and holds the high ground view. Because both audiences stand on the exact same verified bundle in the center, there are no private versions of the truth. A shared, read-only infrastructure is the only logical way for a human lead to definitively audit a machine's architectural claim, hop by hop. This chart compares live tree agentic retrieval with the compiled epistemic map. Live tree retrieval works fine for one-off questions on small, familiar code, but it collapses entirely as an enterprise standard. A compiled map builds compounding value. Every manually checked flaw becomes a permanent test fixture, continuously hardening the verification gate over time. Imitators starting with zero accumulated proof cannot catch up. The fatal flaw of retrieval is that retrofitting an audit trail is impossible. True provenance requires claims to exist as stable, inspectable statements before the question is ever asked. Deploying architecture based on verifiable, undeniable constraints locks organizational knowledge into place. It replaces probabilistic guesses with permanent precision. True understanding of a codebase must be a compiled, verified artifact. Any other approach is a perpetual tax on architectural ignorance.